We've now seen how utility functions and indifference maps are related to one another. But if it still seems a little mysterious to you, let me give you a real-world analogy that might be helpful. Think about mountains in the real world. Now, mountains sit in a two-dimensional plane. We have latitude and longitude, but mountains aren't flat, and so they have a height to them. So they sit in this plane and have height to them, and we can measure that height with different measures in feet, in meters, and centimeters. Different measures exist for measuring height. Now, when we look at a real-world map, we don't look at a three-dimensional map, but we can still represent mountains in those two-dimensional maps. So in a two-dimensional map, we'll just have longitude and latitude, but the way that we can represent mountains is we can take different slices of that mountain at different heights and get a sense of what the shape is on those different slices. And it's those slices that we can graph in two dimensions. That'll give us an idea of where the peak of the mountain is, where the different levels are, and then we can label these levels with whatever metric we used to measure the height. So maybe this is 5,000 feet, and this is 7,500 feet, and this is 10,000 feet. And so by labeling the different levels, we get a sense of how the shape of the mountain emerges in three dimensions. But as I mentioned, there are different ways we can measure height. So here we measured in feet. If we measured in meters, then those numbers would change. But the shape of the mountain isn't changing. And so the way these levels look isn't going to change. It's just the labels because we're using a different metric to measure height. Well, it turns out the same is true for utility functions and indifference maps. And so I've created another animation to illustrate this. So let's take a look. We've seen how we can graph utility functions as utility mountains that have no peak. Here we're graphing the utility function x1 to the 1/2, x2 to the 1/2. And we've also seen how we can take horizontal slices of this function, slices along which the utility is constant, and project those slices into the space of the baskets of goods to give us indifference curves. So these indifference curves have slices along which the utility is constant. So slices that represent all the bundles that we're indifferent between. The magenta indifference curve has a label of 4 because the utility function we used measured the utility level as 4 along that slice. Similarly, the blue slice has a utility level of 2, and so the indifference curve has a label of 2. We'll now change the shape of this utility mountain by squaring this utility function. And we'll see how that changes the shape of the mountain and the shapes of the indifference curves. We'll begin with the two dimensions that contain all the baskets of goods, and then add the third dimension along which we measure utility. Only now we've squared the utility, so the 4 becomes a 16, the 2 becomes a 4, and the 6 becomes a 36. We've just squared the utility function. As a result, the function looks different. It has a slope that's increasing at an increasing rate rather than a decreasing rate as it appeared before. But when we take the horizontal slices, they have exactly the same shape as they did before. The only thing that's changing is the numbers that are associated with the slices, because we've squared the utility measure. The 4 becomes a 16, the 2 becomes a 4, and the 6 becomes a 36. We would say that these two utility functions represent the same tastes, the same preferences, because they give rise to the same map of indifference curves with the labels increasing as we go to higher indifference curves. So more is better. the precise labels don't matter because we don't have an objective measure of utility, and so we can use different measures to measure utility. So in general, any indifference map will have many different utility functions that can represent that indifference map and thus the underlying preferences.